without
Sir,
the help of any medium, right? Example?
sir, like heat from the sun.
Yeah, from the sun. Heat from the sun. Okay, thank you. So
Welcome, sir.
heat from the sun is coming to us with radiation, right? We don't need any medium.
Yes, sir.
No solid, no fluid we require. So there is no conduction, convection, right?
Yes, sir.
Yes.
Yeah. So heat is coming. So what is the process? If there is no conduction and convection, then what is the process? The process
So
is
in between,
radiation, right?
yes, sir.
This is the third way where we don't require any medium. Okay. So you got some other ideas like good emitters and bad emitters of heat, right? In our last class. Hello.
Yes, sir.
So,
Yes, sir.
Yes,
Good and
sir.
bad.
can you tell me please something about those good emitters and bad emitters of heat?
Yes, sir.
Sir,
The black surface is good emitter of heat.
Yeah. Then
sir, why?
If if the if the surrounding temperature is lower, then black body emits heat to surrounding area quickly.
hmm. Then
Again, white shiny surface is bad emitter of heat, as white shiny surface is good reflector of electromagnetic waves.
okay.
Heat
So
IR is one of the electromagnetic waves.
very good. Then we also gave you the idea of good and bad conductors of heat, right?
Yes, sir.
So what can you please tell me about them? Good
So
and bad
example,
conductors of it. Not only example, details like what is good conductor, why they are good conductor, then
Sir,
examples
metals
of
are good conductors of heat
why they are good conductors of it.
because they have free electron in their structure.
Okay, how the heat is transferred in the metals. There is also
The
process written.
molecules vibrate and transfer the heat to the next molecules.
And
And other than that, free molecules move and carry forward the energy across the surface of the metal.
so free
That's why
electrons
they are
are
good
that's
doing
why they
that,
are
conductors.
very
right?
good conductors.
So in metals, we have vibrations of molecules and also movement of the free electrons, right? Which carry the energy as well, right? That's why it is a good conductor. In solids, other solids, they have only vibration, but they don't have free electrons. That's why they are not good conductors. So we in our discussion, we also gave that air particle trapped air. Trapped air is a poor conductor or insulator, right? So
Yes, sir.
trapped air is poor conductor or insulator? Can you please explain? We also gave you
Sir,
the
what is the
example.
question? Can you please
The,
repeat it?
we are talking about trapped air. Trapped air, like the air is trapped somewhere. It's not moving. It's there stuck. So why it is good insulator? We gave you the example.
Yes, sir. The materials which do not allow the heat to pass through them easily are called bad, poor conductors of heat.
Hmm.
Sometimes they
Example.
are also known as thermal insulators.
Hmm. Hmm. Then
Example, wood, rubber, dry cloth, etc.
yeah.
Then trapped air is also a very good insulator, which prevents heat loss by conduction and convection. During winter, we wear warm clothes which have lots of air pockets. trapped air to prevent heat loss from our body to the surroundings and keep us warm.
Yes. So this one, the trapped air idea, we have to be very clear, right? Because
Yes, sir.
because to make our room airtight, or we during the winter to keep it warm, and during the summer to keep it cold, we have to know this idea, right? How trapped air is working. Okay, so that we can use this idea for other context as well. Not all the countries in the world, their weather is not as like as Bangladesh, right? In some
Yes, sir.
areas, there is very cold, even minus temperature, right? In some of the countries, there is very hot, even always the temperature is more than 40 degrees Celsius, 45 degrees Celsius, right? Always, even winter, the temperature is very much close to 40 degrees Celsius. So in those countries, how the people will feel comfort in their house, for that reason we have to know how to control this heat to get in or get out from the house, right? Is it clear? Hello.
Yes,
Yes, sir.
sir.
So we are now uh, going to discuss about absorber. Previously we got about emitter, good emitter, bad emitter of heat. Today we will discuss about good
Observer.
absorber, good absorber and good emitter of heat. Okay, good absorber and poor absorber of heat. Okay, is it clear, everyone? So I'm writing it here. Previously we got good emitter and bad emitter. Today we'll get good absorber and bad observer. Okay, is it clear?
Yes, sir.
So we write it here. Topic 9 continued. Today's date you write 18 4 21. Good and bad
Observer.
absorber. Absorber.
Yes, sir.
On the other hand, white shiny surfaces are bad absorber of heat. Of heat. So have you understood this? Good and bad absorber of heat?
Yes, sir.
Yeah. And after this, you also write other than texture. Texture means color, right?
Yes.
Other than color, heat transfer also depends on surface area, surface area, and surrounding temperature. Aliha. So, so these are two more factors, right? I mentioned here. Hello, hello.
Yes, sir.
Two more factors I mentioned here. Other than color, heat transfer also depends on surface area and surrounding temperature. For example, for example, uh, black body with larger surface area, surface area will absorb more
Heat.
heat than the one than the similar one with sure with smaller area. For example, a black body with larger surface area will absorb more heat than the similar one with smaller surface area. Okay? And
Yes.
about the surrounding temperature, I told you in last class, right? If the surrounding temperature is more, then the black body will absorb heat. And if the surrounding temperature is less, then the black body will emit heat. Is it clear? Hello?
Yes,
Hello?
sir.
So about this we told you in last class. Now the surface area you got the example now. Okay? Everyone, you have any questions here? Good and bad absorber of heat. Any questions, anyone?
Anyone? Okay.
Okay, thank you so much.
No
Now I'm
questions, sir.
sending it in your group, okay?
Yes, sir.
Here is class 8. Class 8.
Yes, sir.
Final term. April. Today is 18, right? We had last class on 15th.
So today is 18.
No, we had last class on 15, right?
Yes.
Today is 18.
Today is 18. Yes.
Yeah. So you got it in the group?
Yes, sir.
So after that, we will discuss one very important and the thing related to our daily life. How long your class will continue?
Sir, more 5 minutes.
More 5 minutes. So today we try as much as possible. Huh? We at least show you, the writing may come later. At least we discuss today. Huh? More 5 minutes means your class is 30 minutes, right? Yeah.
Yes, sir.
Okay. It's 5 to 6 minutes. Yeah. So you see, I'm showing you one diagram. We also told you in last class that we will discuss it today. That is vacuum flask, right? Vacuum flask, how does it work? So you are familiar with this thing, right?
Yes, sir. For drinking tea.
Hmm. Drinking tea only.
Not that. Mostly drinking
For
tea.
storing
Yeah,
hot water.
yeah. Water or for the baby food, right? Like
Yeah.
milk
Yeah.
or any other
Or
things.
soup.
Yeah. So
Juice.
you see here,
Flask soup.
হ্যাঁ,
you
অনেকে
see
রাখে।
class is not over. We have still the class going on, right?
Yeah, 4 minutes.
Okay, look here. Are you seeing the diagram, everyone?
Yes, sir.
Yes, sir.
So
You are.
you see the labeling here: cup, cork stopper, vacuum. Vacuum means, you see,
Empty.
there is inside it there is a container, right? Hmm? Yeah,
Yes,
this,
sir.
and outside there is another container. In between these two there is a vacuum, right? So
Yes, sir.
vacuum means there is nothing, no solid, no fluid.
Empty.
Yeah. Then we have double walled matter or plastic container, insulated support. Then we have hot or cold liquid. You can see in the street we have some hawkers or some very retail seller, they who are selling the ice cream, right? They are selling the ice cream. Have you seen anyone like them? Huh? The people who
Yes,
are
sir.
selling ice cream in the street, they are also using the vacuum flask structure, so that there is no heat transfer, and the ice cream keeps cool over there inside it.
Sir,
It's
where?
not it's not melting, right? The the
Yes.
the container where the ice cream seller
Where,
preserve the
where
ice
they
cream,
put the ice cream?
yeah,
The
preserve the
container.
ice cream. That place, we have the process of heat transfer stop. We know
Yeah.
that is the property of heat. If the temperature is lower than from surroundings, the heat is transferred to the cooler place, right? Isn't
Yes,
it?
sir.
And if the temperature is more inside, then the temperature is going outside. This way the heat is transferred. Now for the ice cream, the surrounding temperature is stopped to come in or get in. That's why the ice cream keeps cool, right? It's not melting. Is it clear? So if you understand about the vacuum flask, how the tea or water or any other liquid we keep cool, the same way you will understand how the ice cream also kept cool. You see, there is another diagram. So, which one do you want to draw? This one or the previous one?
The previous one.
The previous one is better. This one? No, no,
Yes,
this
sir.
not this one. I go back this way. Yeah, this one, right? You wanted this one, right? No,
This one.
this one you want.
Yes, sir.
Yes, sir.
Okay,
Okay.
okay, just you draw it today, huh? That's all for today. In our next class, we will have the discussion how vacuum flask is working. Okay, you just finished drawing today.
Okay, sir.
Thank you so much. Allah Hafiz, huh?
Bye, sir.